And I think we can start the, uh, our lecture. So, so let's talk about Python. I have a small blog about history, but it's very, very small. It's funny because I want to show you the creator of Python. It's Guido van Ross. Very interesting person. I suggest you to read about him because for me, it's like, this is living legends. This engineers who changed the world of technology, and they are living right now with us. And it's like Linux startup, the creator of Linux, and it's a very, very smart and interesting person. So Guido van Rossum worked in, it's a Dutch programmer. He worked in University of Netherlands, and he worked with language ABC. Amazing. I tried to find the logo of language ABC, but it's like this language doesn't have a logo. So ABC is a language for studying the programming, like Delphi, or I don't know, maybe you have some examples of those languages. Basic, yeah. This is a language for studying the programming. It's very, it's looks like a real language. It have many keywords. So when you write the code, it looks like a real sentences, some real commands with the real words. So Guido is Guido have his own philosophy of coding. He's very minimalistic. So he liked ABC because it's very simple. You don't have curly braces, you don't have semicolons. He likes this language, but as a studying language, you couldn't write some complex project. You can't create a real system on it. So Guido liked it, but thought like I can do this with this language anything. So once on a Christmas vacation, he thought, hey, I don't know what he thought, but in my mind, he was like, I will code, like, hey, I am on vacation, I will code some code. And he created Python. Like, Christmas vacation. What did you done on the Christmas vacation? Into nothing. Like, and Guido created Python. And then Python, it's this occasion took place in 1989. So after this, Python started to developing. Many people like Python because its simplicity and minimalism. Then that Python is the main language for AI and machine learning. And I asked ChatGPT why, and ChatGPT said me that it's because ML and AI needs a complicated math. So when mathematicians started programming, mathematicians are not coders. So they needed some simple language to code their mathematician ML stuff. So they just choose Python because it's simple. It's simple. It looks like a real language, and it's not so hard as a Java. And you will see. You remember to install Java, it was a huge pain because I remember on the first lecture about Java, we with Valia like helped you, and we also didn't understand why it's not working on your machines. the a huge amount of versions, some interpreters, and you like, why? Why we can't run this Java program? This Python, you just install it in your command line, and it works. And to write code, you don't need any semicolons and any curly braces. You just write as minimalistic, simple code. So the philosophy of Python, it's very interesting because Python has its own philosophy, and it's a huge thing in Python community because Python developers often like very very snobistic guys. But I like Python philosophy a lot, and you can apply it not only to Python, but to any programming language. And this is Zen of Python, a document that you can have in your terminal if you will write. So if you will write, oh no, do you see my code? It's very, very little, right? Anyway, presentation option. I think I was presentation option. Presentation option. I without the idea that I can say that social media make it for people presentations. Okay, doesn't matter. So what the point? You just write import this, then you run your code, and in the console you can have this like statement then of Python. There is a small document about Python philosophy. So let's check some of these points. Beautiful is better than ugly. So Python code must be beautiful. And I think any code must be beautiful. So your code, you don't want your code looks like a car crash when you have like multiple some included structures in one function. You need to look at a function and have a feeling like you're looking on a great view or sunset, something like this. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. So Python, in Python, we want methods and function be very simple and small, but it's better to create something complex than complicated, because readability counts. It's a very important point because, as I said, you last year, for you as a developer, the main task is not a working code, because when you start programming, you're trying to create the code that works, but as an engineer and as a programmer, your main task to create a code that don't just work, but that could be understood by other programmer. So this is a main task for you. So readability counts. You need to create code that could be readable by other programmers. So, and interesting, now is better than never. This is sounds like some motivational speech, not about programming language, but about life. But for me, now is better than ever. It's about perfectionism, because perfectionism is the enemy of a process, because it's better to uh, it's better to ship your program when it's not ideal and refactor it later, then doesn't ship it at all. And also this one, there should be one, and preferably only one, obvious way to do it. Although that way may not be obvious at first, unless you're Dutch. So in Python, they think that there's only one way to do the task. So we may think we can do this task this way or this way. In Python, because it's minimalism, there's only one way to do task right. And yeah, we will try with you to do everything right. So now let's talk about Python installation. Have you installed Python already?
The process of
Yes. Okay, because I have a slide about this, guys. So to install Python installation is very, very simple. So if you have Mac, you can install it with Homebrew. If you don't have Homebrew already, you can write in your browser install Homebrew, and you will find something like this. You don't need to write it from the screen. And then with Brew, you will be able to install many packages on your Mac, not only Python, but like any. And then with Brew, you can write Brew install Python. We will use Python 3.12. So please install Python 3.12. And after this, you will be able to use Python 3.12. You will be able to check this in your terminal. And if you don't like writing Python 3.12, you can create an alias for Python, and you will be able to write Python, not Python 3.12. Okay, so then for Windows users, it's simpler. You can go to the Python
Microsoft Store.
or Microsoft Store.
I have we have 11 or 1 to 10.
What?
We have Python versions 11, 12, and 13 at least. But then
Okay. Yeah. So, but you can go to the Python website and find the installer, install it. Do not forget to add Python to pass to check this checkbox. And after installation, you can check if Python is installed. And this is it for installation. It's very simple. During the class work, you will be able to install it, but you can do it right now. I think we will do a small pause after some information, and then we will continue with Python syntax. So also, you need some IDE for this. I think you already have Visual Studio Code. I will use Visual Studio Code, but you can use any IDEs you want. It may be PyCharm, IntelliJ IDEA, what you want, what you prefer. But I suggest to use Visual Studio Code. Okay, a little bit about command line. On this course, we will use command line a lot, because as a backend developer, you need to work with command line a lot, because when you will work with your server, there will be no buttons and interfaces. There will be only command line. So you need to be able to work with it. During the class work, you will show me your skills with command line. Here you can see some actions, but I created a slide about those actions only for Unix systems. And this is, I didn't thought about you guys with Windows, sorry. But you can find in the module, you can find information about commands for Windows also, but you need to be able to create a file, create directory, move through those directories, print information inside directory that you are in right now, remove files, remove folders, etc. So yeah, and let's move on to Python syntax.
So let's continue. We have a bullet train section of Python syntax, because you're already developers, you already mastered the Java, so you already know how to write the code. So I just show you a syntax of Python and give you a class work assignment, and you will be able to write Python code right away. But I didn't thought that the summer, 3 months without coding, right? Oh no. Okay, I think you'll figure out something. So let's go. In Python is a dynamically typed language, so you don't need to declare the type. To declare a variable, you just need to write it like this, and you can see that in Java we have used what type of naming? Camel case. And in Python we use snake case. So in Python, names and functions we write not in camel case, but we separating our words with underscore, but not for classes. Classes written in Pascal case. So Python know what type do you using in the runtime, so you don't need to explicitly type it. Here you can see the example of string, bool, the list, the table, and the int. So, for example, I don't know, let's try something. We can create our name. As you can see, we are not using any semicolons. Cool, great. Then we can create, for example, user profile, and here you can create, for example, thank you, Copilot, I don't need you right now. But okay, I like what he proposing. So as you can see, in our table we can create the key that is string and value that is string, but also key, string, and value int. And for example, hobbies, I hope I wrote it right. And hobbies, for example, can be a list of strings, for example. So These variables, nothing hard. Then conditional statements. You already know about conditional statements: if, else if, else. In Python, it looks like this. So let's create some Boolean variable is active. Also, you can see that in Python, true and false written from the upper letter, not from the lowercase. So let's create some conditional statement. If is active, then we writing the, what's the name of this symbol? Not a semicolon, double colon, you know? I think they have some particular word for this. I will call it double column. So, as you can see, if in Java we would write if, then we would write brackets, then brackets like this, and inside those brackets write some code. In Python, we don't need anything from this. We can write only the if keyword, then our statement, and for example, if we have few variables in Java, we would write something like this for end. In Python, we just print end, and this is what I told you before. Python looks like a real language. You don't need those logical operations. You just write end. So then we are printing double column, and we don't need any brackets, because then we just print our code under the if. But you can ask me, Vlad, but how Python knows that we need to print it only if this condition is true? The key is in these indentations. So in Python, instead of curly braces, we use those spaces. So you need 4 spaces or 1 tab, but I think 4 spaces is better, to show the Python that we want to write this code, we want to execute this code if this condition is true. And we can, it's not like in Java. In Java, we also can don't use the curly braces in if statement, but only for one operation. Here, we can do it for any operation. And you can see that if I don't, so let's create this situation. For example, our statement will be false, because is active true, but is cool false, for shame. And this means that we will not have user is active and cool, but this print is in code without those spaces. So if we will run our code, and we can run it in a command line, just we need to just type Python and the name of our file, main.py. You can see that we printed our user profile, but we didn't print the user active and cool. And if I add 1, 2, 3, 4, or just 1 tab, and save the file and run it again, you can see that user profile don't print it anymore. And if I will make isSchool true, you can see that we have two prints because print now in this code block of this if statement. Then we can write, we have keyword elif. It's like else if, but simpler. So elif is active and isCool is not cool. So in Java, how this statement would look in Java if we want to say not isCool? Yeah. In Java, we would write something like this, but in Python we are using keyword not. So is active and not isCool. We write in user is active but not cool. And also we have else. And this is it. So let's run it. As you can see, user is active and cool, and user can be active but not cool. So I think it's pretty simple for you because you already work with this. This is just syntaxes. There nothing new for you. Let's move on. Loops. We have two types of loops. We have for and a while. So it works like conditional statements. For example, let's create a list. List of numbers. Okay, Copilot, as you wish. So we just type in. Please do not use Copilot. I will turn it off next time because.
The funniest option with my Copilot is that not only I didn't enable it, I didn't even set up properly, so it can't even move in a bit more.
I'm using Copilot for work, but I will turn it off. So I don't want this temptation, and I don't want this соблазн to to use it while I telling something to you. But this looks pretty similar as in Java. There are only syntax differences. So we are using double column, and we are using those spaces instead of semicolons. The same principle, but with for and while. You work with for and while, it's not a problem for you. Functions. Let's write some function. Okay, who want to help me? Yeah, he is. But maybe someone from real human. Let's create some function about something. Please help me about what we need to create our function. Copilot? Okay, Copilot, you're always there. They are not there for me. No, guys, please. For example, we have user profile. What we can do with this user profile?
ToString function.
ToString function. But why do we need this if we can print this? We already have ToString implemented in. Not automatically. I think someone wrote it somewhere inside Python. I think not in print, but in this map data structure. But we will talk about it later.
Maybe with age frames, assume whether it's kids, adults, range.
Okay. So how can we name this function? So to create a function in Python, we are using def keyword, like define, I think. No? I don't know. It doesn't matter. Def. So def, and what are you proposing? Because Copilot already proposed me a nice idea. So if you will think too slow, the Copilot will take your job. Fibonacci sequence. Okay, you can go here and write it. Okay. Okay, so how to name it? Okay. Do we need some arguments in this function? Okay. Age. So we passing age like this. We don't need the typing. Okay, user ID. Then we are writing our double column, and then we can write the body of the function. So I think we need to check if age. First of all, I think we need to check the user ID, right? And we need to add, first of all, user ID. So I'm writing already these brackets. So if user ID equals Copilot, stop it. If user ID equals 0, we do some stuff. Else, we not doing anything. For example, we user not authorized, but if user ID is 0, we can check its age. But as you remember, in Python philosophy, we need to create small functions. So let's create another function for calculation of age. So person age calculation, for example, and we will have age as a parameter. And look, I want to print already in this function, print a person age calculation, age, for example. But how can I know that this function, person age calculation, will return me an Boolean statement? So I want to this function return me true or false. Why true or false? Maybe not true or false, but string about user age. So to have a type hint, of what our function will return, we can write Copilot, stop it. We can write the minus and arrow str, it's for string, and in this way Python will know that this function returning string and only string. And then, thank you Copilot, we have such function, and I think everything will work. We can just ten. For example, we can run our code, and we can see that user not authorized, and if user ID is 0, you are minor. Thank you Copilot. Okay, I will turn you off. Okay, so exception handling. You already work with the exception handling. Try. Here you can use try. If you have some exception, you can choose the exception type and do something about this. Okay, let's move on. Decorators. Oh, this is where your pain is started, because decorators is pretty complex topic for beginners, but we need decorators to create our own framework. So let's try to understand what is decorator. So basically, we have some function, for example. Some function for example, what function we had here? Define person. For example, when we are running this function, we want to log information about this person in some file, in txt file. You work with this in Java. So what I need to do to add this functionality to define person? There are no right answer. I think your answer will be wrong, and I will tell you what is decorators and why do we need them. But imagine the task in Java, for example. You have a function, define person, this function where we just checking the age and printing something. And Roman saying, guys, please add functionality to log information about user, to add into the file information that person, that user with ID, user ID, and age, this age at that time tried to define person, for example. How, I don't ask you how to add, how to write this functionality. How you will add this functionality in this function. So I think you can just take this function and, for example, at the beginning of the function, add this functionality, like take user age, user ID, open file, write it to the file, close the file, and then do this task. So we can even move it to the another function and like create some new function, for example, def log user info. We can take our age and user ID. Oh no, I'm Java person. And like do something like this. If you want to create the function but you don't have implementation for it, we can use keyword pass. So you can do this, and you can add this function here. But in this case, you need to change the already existed function, and this is not okay, because it's in a solid. Do you know solid? I will tell you about solid. What? Yeah. So it's open. Dima, help me. Open closed, right? What? Open closed. So modules need to be open to adding new functionality, but closed for changing existing functionality, right?
Yes.
Yeah. So if you do something like this, we are changing existing functionality. But what we want is to add new functionality, add new method, but not update our previous method. And decorators needed for this. We can create our log user info as a decorator. So what is decorator? Decorator is a function that takes as an argument function and returns updated function. Wow, yeah? And it's only start. So, for example, we have log user info. And this function takes as an argument not age and user ID, but as a function. And in Python, everything is an object. Variable age is an object. Our function is an object. We can use our function as a variable, basically. So we can pass our defined person into this function. So it takes some function. For example, define person. And then inside our log user info, we can do some logic, then run our function and return updated function. So let's try to create it. So thank you, Copilot. I love you. So what we have here, look, we have function log user info. We are taking function as a parameter. So imagine, I know, let me create some example for you. So function, as you remember from previous course, is just a declaration of some algorithm, right? So it's just a blueprint. When we write function like this, it doesn't mean nothing. It's we're not running it. We just wrote it some like instructions for future. And when we are calling the function, in this moment we are using this blueprint to run operations. So imagine that we can pass like a link to our function declaration here. So we don't know what function it is. We know that this function log user info just having as a parameter some function that it can call in runtime. It can be any function. So then inside our function, we are defining new function, wrapper, that takes our age and user ID. And then we print this information. You can imagine that we are not printing, but yeah, doing something else. For example, we writing in a file, as I said previously, but here we are logging like this. We just printing it. And then we are returning our function, our previous function. So what happened? And how to use decorator. We use it, please don't be afraid, guys. We using it like this. And it needs to be here. We're using it like this. And let's try to run it. Object is not callable. Because maybe because of this. Why? Yeah, it's this. So what I did wrong? Okay, I see.
In your example code, the return in like the big log user info event, you are just returning wrapper instead of returning func with brackets. So just replace this with wrapper.
Yeah. Okay, but we are. Okay, yeah. Makes sense. Yeah, so as you see, we have our login and we have information about a person. So what happened here? This is just syntax sugar. So when we're writing something like this, we're saying that we want this function. I will use my laptop so guys online can see it. So we're using this function to wrap this function. So basically, as you can see, log user info takes some function as a parameter. And when we're writing something like this, we're saying that we want transfer. What? Yeah. We want to transfer this function as a parameter of this decorator from 1 to 10. Where are you now, guys? 3. Okay. So, interesting. So basically, we can use our decorator like this. We can remove this line and write something like this, and it will be the same information, but with two logs. Because we have a decorator, we can remove a decorator, and as you can see, we have the same result. Why? Because, and what does it mean? So we have function log user info, and we pass to this function our function define person. And if you can, if we can check our log user info, what our log user info does. It have function as a parameter. Then we are defining a wrapper function inside this function, and this wrapper returns a function. So we are returning this function. Okay. I think we will come back to decorators later, because now I understand how complex this topic to explaining to you. I think we will be back. We will talk about this in the next lecture. Okay, I will create some visual metaphors for you. For now, let's skip it and move to OOP. Nothing complicated here. Just our regular OOP. So let's create some class.
Sorry, what is all? But how I can use comments here?
Comments?
Yeah.
You can use comments like this, or
okay, thank you.
or like this. Yeah. So when we create a class, we create it like this. Then our double columns, and then you remember from Java that we had constructors, right? And fields. We needed to define fields and then create the constructors and methods and so on and so forth. Here we have magic methods. I will talk about them a little bit later. But what we have here is magic method init, and this is our constructor. So then, if we want to create some variables inside the class, we don't need to specify them in the body of the class. We need to specify them inside our init method. And we need to use self keyword. Self is like this in Java, the same concept. So basically self means that this is a field from this class, from this object that you are using right now, that you have created. So for example, name, and we can have name from the constructor as in Java. And if you want to say that name is a string, so previously in our functions we didn't wrote any types for our variables. If you want to say that name is a string, you can use our double column and type it like this. So now Python knows that name is a string. And the same thing here. If you want to say that age is an int, we can write it like this. Okay, so we have name. Let's have an age. And now we can define our variables, our fields in our class. So we can write name equals name, self age equals age, and this name, it's not the same as this name. This name can be called like person name, and this is different variable, and this is a field of this class. And also we can create other class, and we can inherit this class from person. So we can create an employee, we can have the same fields, name, age, and also employee ID, for example. And then we can use super method. This is the same as in Java. It means we will run our constructor from our parent class, and then we can do other logic that we want to do in our constructor of employee. So basically what we have here is that we're saying that we like the logic from constructor from person, we want to define person name and age, and also we want to define employee ID. Yeah, so this is it with classes and method overrides. So how it works in Python, you work with this in Java. For example, we have some method info. When we are working inside, we're writing methods inside the class. We need all the time to pass self to show Python that so we could use information from this object of this class. So when you write a function inside class, you need to write to pass self in it. So we have such a function that returns information about our person, and we can override this information. As you can see, we can use our super info. So we will call info from the person class, and then we will not print, we will have this string, we will save it in variable base info, and we will return new string where we write in our base info plus employee ID. So we overrided our person class method info without this, because in Java we used annotation override, but in Python annotation is a decorator. So we just overriding it like this in Python. So then special methods. Interesting topic. They also called magic methods. Why they called magic methods? Because to call this method, we do not need to call this method. We defining some logic inside those methods, but they triggered in other situations. For example, in Java, you remember you had opportunity to override the operators. You could say for this class, plus means something, or equals means something, and you write it like this operator inside class, override this operator, and then you had a object as a parameter, and you said like this and other object, if someone saying that person plus person, it means new return new class person, something like this. Here we don't have this type of overriding the operators. We have magic methods. For example, we have EQ magic method. This is the same as overriding the equal. So we write in that EQ, we have self, so we have our object that we are using right now. We have other, this is other object. So if someone have two products, for example, product 1, product, someone saying if product 1 equals dyslexia, product 2, print something. So in our product class, Python don't know what to do when someone saying this object equals this object. But we can define this behavior with magic method EQ. So as you can see, for product, equals means that name equals and price equals. So in our example, for example, we can define equal and we can write something like this, and not very beautiful function, but you get the point. So now if I will create employee one, employee 2, and we'll print employee 1 equals employee 2, we will have false because there are two different employees. But if we will say that employee 2 have the same information, it will say true. So with magic methods, you can see we define some strange EQ method, but it triggers when we doing some operation. Also, init is a magic method because we defined a magic method init, but we never call it. It's called when we creating our object, when we doing stuff like this. So there are many magic methods. You can check them. You have a magic method for casting to some types, for example, string. So if we will write str magic method, this is the same as toString. So when I will print my product, I will be able to print information. So I can show you, for example, if we will create and we can even use our info method. and we need to use self because this method inside this class. So if I will print employee Odin 1, why Odin? What is Odin? I don't know Ukrainian. I need to cast it to string. So also another topic, how to cast variables and objects inside Python. You need to write the type, and inside it's not brackets, right? It's I forgot. Braces. Curly braces is forget it. In Python there are no curly braces, but some of them, yeah, but not inside the function and like stuff like this. So we need to cast it, and why it's not working?
Maybe because of tabulation.
Tabulation?
So tab, yeah, it's not.
Yeah, but it's not a problem. This method, this print is working, but I'm printing some information. Okay, and if I see. Thank you very much, guys.
That was a meeting.
What? And now it's working. So thank you. Let's move on. Public, private, and protected. You already know those things from Java. So how to create public, private, and protected variables, fields in Python. In Java, you used keywords, public, private, protected. In Java, you use underscores. So name without underscores is public by default. With one underscore, it's private, right? Or protected?
We don't know.
Me too. So with one underscore, it's private. With two underscores, is protected. This is everything you need to know. And usage, I already showed you the usage. So maybe you have some questions. Okay, so guys, you already real programmers, and it's not hard to you, it's not difficult to you to learn about new language, because you already have knowledge about all those concepts. So when you have a problem, how you can just Google or maybe ChatGPT, like ask, explain me how this concept works in Python. Some concepts that you know from Java. Yeah, and they will help you. So